Welcome everybody on behalf of the Institute for Policy Research here at the university. I'm Nick Pearce, I'm the director of the Institute. In our work we focus on research in our doctoral programs and our events on major public policy issues and challenges, some of which the Vice-Chancellor referred to in her opening remarks, and none perhaps are more important than climate change. So we are delighted that Professor Barrett is here not just to receive his honorary doctorate, but to lecture us on how to and how not to save the planet. And I think it's particularly appropriate that we're here to discuss and debate those issues this week when it's been confirmed that the Paris Climate Change Agreement has come into legal force, or will come into legal force on the 4th of November, with enough countries now having ratified it that it will become legally binding. So a very important moment for us to debate and discuss when these kinds of international cooperation agreements do and don't work. Professor Barrett.
Well, thank you very much. This is more than an honor. This is like a deep pleasure for me, and thank you for coming. I appreciate that. I can be more relaxed now, I think. Is that correct? A little bit. First of all, Michael, make sure I keep to my time. Can you make sure I get a warning in about 10 minutes? As you noticed from before, I could go on for some time. But let me just start off by saying that when Michael first, now I can say this, that the formal ceremonies are over. When Michael first said to me, Scott, how do you feel about getting an honorary doctorate? I said, you're joking. He said, no, I'm not joking. I said, you're joking. I said, no, I'm not joking. I said, but Michael, honorary doctorates are for big shots and old people. And Michael said, but you are a big shot. And you're an old person. No, he didn't say I was an old person. But that reaction I think will stay with me. It's quite amazing. I wanted to talk to you about something very important, and it is about what we can do as a planet, as an aggregation of people, to protect the Earth. Not for itself, really, but for us. So the newspapers, particularly in this country, like to talk about saving the planet, but really what they mean is acting collectively to make sure that we protect the resources of the Earth for our own well-being. And I don't know about you, but I don't think we've done such a brilliant job of it. And particularly in the area of climate change, while I will say quite a few things, I think we've done quite a terrible job of it. And what we need to do is not just be upset about that, but to know how to do better. And the only way to know how to do better is to first understand why we got it wrong up to now. Because unless you can explain why things have gone wrong to this date, I don't think you're in a position to really recommend how we should be doing it, how we can move forward. What I want to do in this time is to tell you, I'd say that the most important single lesson I've learned over the last 25 years of doing work in this area, and I'll just give you the synopsis now, and that is that the world is not very good at voluntary contributions to address problems like climate change. The world is exquisitely good at coordination. And we've basically spent 25 years trying to do what we're not good at. And I think it's time we started doing what we're better at. So that's where I want to take this, and there'll be an agenda at the very end of the talk. So I can move away from the lecture, is that correct? Okay. So let's talk about saving the planet. Again, this comes up again and again. And the point I really want to make to you is that the people who are engaged in this effort on our behalf are really not trained to know how to do this. I mean, a lot of these issues are unprecedented, so fair enough. But also, in my experience, the people who are engaged as professionals in this area of diplomacy
actually don't understand that there's not only a science of climate change, there's also a science of international negotiations. And it bothers me that they proceed along paths without having any knowledge as to whether those particular paths they're choosing will be successful. I think we can do better. So just to sort of set the bigger picture, it's about as big as you can get, we think of, I mean, people trained in the natural and physical sciences and so on tend to think of the world in this way, as there being one world, this beautiful blue diamond, as it's sometimes called. But the reality about, so I'm already missing some words here. So I wonder, is this the PDF? Do you know? Is this the PDF? Okay, we're already missing some words here. So, but this is another representation of the same world. But notice here, instead of having just the natural phenomena there in front of us, you now have the geopolitical map of the planet, where you start to see there are nation states. And the essential thing to understand about these issues is that the problems are derived from these institutions of states, and the problems will have to be addressed by these same institutions. And you basically have a kind of a collision between these two different kinds of worlds, because these worlds here, these nation states, which serve us well in many, many ways, are completely the wrong kind of institution for addressing a whole global problem. And here's the one I want to spend a lot of time on, although I will mention some others, and that's climate change. In this particular picture, which is a computer graphic, you're seeing carbon dioxide as it's being released into the atmosphere. That's the orange and yellow, and of course it's in the higher latitudes, closer to where the population centers are, where manufacturing is, and so on. These molecules become quickly assimilated and spread more or less evenly around the planet. And they affect the climate for everyone. So individuals like us and countries cause emissions to be entered into the environment, but all countries and all people everywhere and in the future will be affected by those decisions. So this is what I want to understand. You know, if I were an expert on wildebeest, I'd show you a photograph of wildebeest. Well, I'm interested in these people and what they do, about the negotiations. And the way I tend to think about them is that they're playing a game. This particular picture, I think, comes from a James Bond movie. I'm afraid I don't get out very much, so I don't know, but I believe it's from James. So basically, I want to go back and forth between this, and this picture here is an abstraction of the picture we saw before. So the way to understand the negotiations is not to get too close to them and stay there, but rather to pull back, to think abstractly, and then go back in and see if you can understand things better. And I think one clear way to understand this is to play a game. So I don't have the time to play a game with you, but I'll tell you about a game I've played hundreds of times, literally. And imagine that I've given each of you two playing cards, a red card and a black card. So everyone has two playing cards. Everyone knows that everyone has two playing cards. And you must hand back to me one of your cards. Now, which card do you hand back to me? That's up to you, but you should know the consequences. And the consequences are, if you keep your red card, you gain 5 pounds. And you get 1 pound for every red card handed in by anyone. Now, if I played this game with you for real, what do you think would happen? I know you're a special audience, of course. Goes without saying. But I played this game a couple hundred times, at least, with every kind of audience you could imagine. Real negotiators, only environmentalists, only economists, only people from West Africa, and so on. And the results qualitatively are always the same. Some people hand in their red cards, and some people don't. And that the ratio of people handing in the red cards tends to be between 1/3 and 2/3. Okay. Now, it's in everyone's collective interest that everyone hand in their red card, because let's say there are 200 people in this room. If everyone handed in a red card, then everyone would get 200 pounds. But there's a tendency for people to want to hold on to the red cards, because no matter what everyone else does, you're always 5 pounds ahead if you keep your red card. So the outcome could be that everyone gets 5 pounds because they held on to the red card, when it would have been possible for everyone to get 200 pounds. Now that game is called the Prisoner's Dilemma, and it pretty much, or the linear public goods game, and it pretty much characterizes the problems I want to discuss today, and especially climate change. The reason we failed to address climate change, I don't think it's for the reasons you often hear about. People don't believe the science, and there's no political will. I mean, you always have to ask, why isn't there political will? I think the reason is because this is a supreme collective action problem. This is as technical as I'm going to get, but I do want you to look at this picture because it's a graphical representation. We're at university, so I should do this. I'm obligated to do this. This is a graphical representation of the game we just played. Here I'm assuming that there were, I didn't know the turnout would be so great, so I assumed 100 people. And what you have here are the number of the other people who hand in their red cards, okay, on the horizontal axis. And these are the other people. There are 100 in the room, so you're one of those people. So from your perspective, there are 99 others. And this is the payoff you get that depends on what you do and what the others do. So if no one else hands in the red card, and you do, you only get the 1 pound for handing yours in. Of course, everyone else also got that 1 pound. And you get 5 pounds if you kept your red card, given that no one else handed in the red card. And if you go to the other end, if everyone else hands in the red card, you get those payoffs on the right. And obviously, you're much better off. The best we can do as a group is for everyone to hand in their red card, and then everyone would get 100. But if we fail, we're down at this end, and everyone ends up with 5. Okay? So in many ways, the task of international cooperation is to somehow get the world to that open circle on the right axis and away from the closed circle on the left axis. So think of it that way. But what's driving behavior are the positions of those curves. Because as long as the blue curve is on top of the pink curve, the incentive is always going to be for the individual not to contribute. And I think we need to take that seriously, because that seems to have a big effect on behavior. So for the group as a whole, everyone should contribute, but individuals will be thinking, even if everyone else contributes, if I hold back, I get even more. Now, people have many impulses. That's not the only one. So I don't believe that people are only motivated by greed. Of course they're not. At the same time, I think it's very important to not to be too false in how we understand things, because self-interest is a very powerful motive, and you certainly see it in these international negotiations. Now, Astrid and I have played these games in experiments, and this is one of my favorite pictures. This, by the way, I think is a picture, an image of the climate negotiations. I'll explain why. What you have on the horizontal axis, these are the rounds that teams are playing. So these are teams of 5 people, groups of 5 people playing, 5 individuals as groups playing. And this is the first round, and it goes down for 20 rounds. And what you're seeing on the vertical scale are the number of people who are, in a sense, handing in their red card. Okay? So what you see on the far left, when the game first begins, 3 out of the 5 are handing in the red card. And then the next round, 2 hand in, and then 1, and then 0. And then 0 again. And then you stop, and there's a pause, and then you play the game over again. And people come back with renewed optimism, despite how things went the last time around. And they come in, let's try it again, and let's do it this time. Okay, now 2 contribute, 1's dropped off, and then 1, and it goes down to 0 again, 3 rounds, 0, 0, 0. Okay, we try it again. Okay, one more time. Come on, we know what we need to do. We have to supply this public good. We need to save the planet. 1 person contributes. Cynicism is creeping into this room. You can just feel it, right? You know how it goes. And then 0, 0, 0. And when you get to the last one, they get to try again. No one contributes. And now everyone is deflated. And this pretty much is how I've understood the climate negotiations. I think it's followed that kind of pattern. So every time we start anew, there's an excitement. We can do it. All we have to do is try again and be a little more determined. And and no, we have a hard time getting off the ground. Now, why is that? Well, when you look at people like us, one thing we find in experiments, I say we, I mean Astrid and people in that area, is that some of us are what are called conditional cooperators. Altruism is actually fairly rare, quite rare. But many people are conditional cooperators, meaning that they're willing to contribute provided others contribute. And that's really quite important to them. So the reason you tend to get quite a few people contributing at first is that a number of people are conditional cooperators. That's shown again and again and again in experiments. But what happens over time is that cooperation falls. One reason it falls is that people tend not to contribute one for one. In other words, suppose that we're playing with many cards and the average of all of you contributed 5. Now, if I were a free rider, I contribute 0, but as a conditional cooperator, you know, I might respond with to your 5 with 4. And imagine we're all doing that. So no matter what all of us does on average, each of us the next round does a little less, and then a little less, and then a little less. That puts you down in this, like this. The other thing that drives behavior are the number of free riders, the people who don't contribute anything. And they really bring down morale. So they just bring the whole thing down very rapidly. These things tend to show up again and again in experiments, and I think they show up again and again in international negotiations. So there's a picture of Sisyphus. The errand is a bit like Sisyphus, his assignment to push this boulder up the mountain. And of course, as soon as he gets to the top, it rolls down again. He has to go and do it over and over again. That's kind of how I've understood the effort of cooperation in these situations and in the negotiations. Now, what helps? Well, communication helps, but it tends not to have a persistent effect of helping. So it helps, but isn't enough. And you know, the one thing that international negotiators do and are good at is communicating. They talk a lot, as you probably noticed, but that's not enough. Something that helps are punishments. Punishments meaning that if others, let's say the free riders don't contribute, maybe the conditional cooperators can punish them. And if the free riders know that they'll be punished, maybe they'll modify their behavior, even if they're still interested only in their own self-interest, and contribute. But what tends to happen is the punishments are effective only if they're very efficient, meaning that it costs the person I'm punishing or the country I'm punishing a lot more than it costs me to impose the punishment. Because if the punishment hurts me a lot, I'm going to be less inclined to want to do it. I get emotional. I will do it sometimes, for sure. We're all like that, I think. But it's harder to do it when it's going to cost me a lot, and I know it's not going to cost the other person or the other country that much. So that's one of the things. Another thing is that in these experiments, people actually have to punish in order for behavior to change. And when you punish, you're actually bringing down the payoffs. So when we played this card game in the room could potentially, well, the room, let's say the one on the screen with 100 people could potentially get 100 euros each. Well, if we're punishing each other, we're not going to get that. We might be down to 40 or 50 or something like that, or even worse. And finally, if you allow everyone to retaliate, what can happen is different players are punishing, and you can even have the free riders punishing the conditional cooperators early, just to sort of warn them, don't punish the free riders later on. And so you get a lot of punishment going all over the place. And that starts to approach Thomas Hobbes's idea of what society might be like without a sovereign. So this image here is from Hobbes's famous book, Leviathan. And he says that the way to address these kinds of problems, these public good problem, collective action problem, a sovereign is needed to keep people in awe and tie them by fear of punishment to the performance of their covenants. So the covenants are the agreements they enter into for mutual gain and to make sure that people fulfill those pledges, those undertakings. They would be punished if they didn't, and that would in fact give them the real incentive to behave well. And this idea found favor with Garrett Hardin, who wrote a very famous article published in Science in 1968 called The Tragedy of the Commons, in which he said the tragedy of the commons requires mutual coercion. So coercion is about punishment, mutually agreed upon. So now he's thinking about how we arrive at decisions as a collective by the majority of the people affected. So he's actually pointing towards democracy as a remedy for this. He very much follows on Hobbes. Now, Elinor Ostrom, who won the Nobel Prize in Economics some years ago, the first woman and also a political scientist, she's famous for her work showing that people, at least in smaller groups and in local communities, can cooperate. And in fact, she has argued that cooperation at that level is better than having the sovereign come in with threats of punishment and so on. So there's a case to be made for self-organization at the societal level. However, Lynn and colleagues looked at whether this would apply at the global level. She said, well, there are three reasons why it's more difficult. One is scale. There are a lot more people. It's true there are, of course, more people, but people are aggregated, and we actually have governments to negotiate on our behalf. So I'm not sure at that level whether the number is that unusual. We have around 200 countries today. Diversity, this is obviously very important. Cultural diversity can decrease the likelihood of finding shared or common ground. And if the world has, if people have very different values, they perceive things very differently, then this is always going to be a block. That's a big problem for the world right now, these differences. And finally, and most importantly, and what I want to focus on is the law. Basic collective choice rule for global resource management is voluntary assent to negotiated treaties. Like, this is fundamental. Even if you sort out the other problems, you still have this one. Now, what sovereignty means at the global level, countries have sovereignty under international law, which almost means that they can act as they please. It's not quite that, but it almost means that. It does mean there is no world government. Now, you can have very rare instances in which the UN Security Council will take measures that are legally binding upon all members of the United Nations. But this is very extraordinary, and more importantly, it only will have full effect if the Security Council, and especially the Permanent Five, are willing to enforce those resolutions. And in the past, that's where the weakness was shown. If you look at international organizations, they rarely, very rarely, make decisions by majority. It's not like a democracy. That the rule that tends to dominate is that you want something like a consensus. For example, all decisions by NATO, there was never a vote taken. They're all undertaken by consensus. And finally, and most importantly, participation is voluntary, meaning that if you don't like what the group is doing, you can just walk away. You wouldn't know anything about that in this country, would you? But you know, that has always been the case. Even if it doesn't happen, the threat that it might happen is always there. Always. And it's always been there in the European Union, although I'm not going to talk about that. Let me just make it clear by an example what the difficulty is in moving from the national level to the global. So I'm going to compare on the left in the blue a very important law adopted in the United States for regulating emissions that cause acid rain, but also a lot of human health problems. And then the Kyoto Protocol on climate change on the right. Both of them have obligations to cap emissions. So for Title IV, it's sulfur dioxide emissions. For Kyoto, it's greenhouse gas emissions. They both allow trading, something economists are very enamored of. Now, look at monitoring. Very precise monitoring of emissions at the power plant, at the stack level, under the US law. But under the Kyoto Protocol, you have self-reporting. So this is where sovereignty is starting to creep in. I tell you what I've done. You know, you've heard that China, we thought they did one thing and then they've done something. And this is how the international system tends to operate. I'm not saying there are no exceptions. There are some exceptions, but it tends to operate this way. Participation, of course, is mandatory under the US law. All plants that are covered by that law are forced to fulfill these obligations. Whereas under the Kyoto Protocol, of course, participation, as I said, is voluntary. So they don't have to participate. And in terms of compliance, there's a penalty for non-compliance under the US law, which is so high that compliance literally is 100%. 100%. Thomas Hobbes, well done, it works. Whereas under the Kyoto Protocol, you have more or less a mess. You have Article 18, which actually says if there is to be any compliance mechanism that applies with binding consequences, then it must be agreed by an amendment. Now, a couple things to know about this. First of all, there is no amendment. And secondly, even if there were an amendment, it would only apply to the countries that ratified the amendment. And of course, they can pull out later too. So enforcement at the global level is completely different than at the national level. Now, when the negotiations, for example, the most recent ones in Paris were publicized, you probably heard that a lot of people were very concerned that the agreement be legally binding. The Europeans, for example, very, very strong advocates for legally binding agreements. But we had one before the Kyoto Protocol. Canada, doesn't everyone love Canada? How could you not? Canada loves international law. Canada, unlike the United States, ratified the Kyoto Protocol. However, Canada never adopted legislation needed, never, and was going to miss their obligations under the Kyoto Protocol by a long shot. So what did they do? Well, one option, they might reorient their whole economy and try to do it at the last minute to do that. Another one is they might have used this market mechanism to pay someone else to do it for them. They didn't do that. The easy one was just to walk away. That's what they did. So after this meeting in Durban, South Africa, Canada's environment minister went back, and as soon as he landed in Ottawa and gave a press conference, he said Canada was withdrawing from the Kyoto Protocol. That is how the international system works. And that's Canada. Okay, so it's not North Korea, okay? I'm just trying to get you to understand, that's Canada. Everyone loves Canada. Canada is the biggest advocate for international law, and yet Canada did this. This is the system we have, and this is the system we have to work with. The climate negotiations, okay, it's very simple. You need an agreement that does three things. First of all, every country, or all the big ones at least, but every country, let's say, is in, number one. Number two, you have full compliance, so they all do what they said they were going to do. And number three, they have to agree to do a lot. This is very important. To stabilize temperature, you must stabilize the concentration of the gases in the atmosphere. When you put greenhouse gases in the atmosphere, CO2, some of those, a percentage of the volume we throw into the atmosphere will stay there for thousands of years. This is a longer-term problem than nuclear waste storage. I'm pausing because people really have to understand how great this challenge is. So you ultimately need to stabilize the climate. You ultimately need to bring emissions towards zero. There are a couple other things you can do I'll talk about later, but you ultimately need to bring emissions towards zero. This is completely without precedent. You have to reorient the entire global energy system, which basically means the entire global economic system. We've never done anything like that. Okay? We're going to do it for a collective purpose, the card game, not just because it's in our self-interest. That would be easy to do. It's not the Industrial Revolution. This is one that we need to cultivate and develop, and that's what's so hard about it. So that's what we have to do. If you look at the climate agreements, the first one, the Framework Convention on Climate Change, 1992, that one, everyone's in the agreement, full participation, they all complied, but that's because the agreement doesn't require them to do anything. Okay. The Kyoto Protocol. Now that Kyoto Protocol asks countries to do something. Not actually an awful lot, but they asked some countries to do some things, and you can see what happened. The United States didn't ratify, Canada did, and then pulled out, and actually since then it's disintegrated more. Even Japan just walked away. Russia, New Zealand, okay. And that's because it did require that something be done, but it provided no means for enforcement. Copenhagen, what they were going to do was they were going to do Kyoto, and then they were going to really do it. I mean, they were like, take this thing that wasn't working, and they were going to make it even bigger. Wow. Not surprising, that was not going to work. And then they tried to get it in Paris. Now in Paris, what you have, you'll have something close to full participation, if not actually full participation. You won't have to worry about compliance because there is no compliance. They agreed that from the beginning, except for very minor measures, that the obligations the countries have put forward are voluntary, and that's the way the whole agreement was established in the beginning. They're voluntary. And then finally, require the parties to do a lot. Well, they don't require anything. You make an individual pledge for what you're willing to do. There's no negotiation about the numbers. Okay? So that's why Paris succeeded. Okay? We really couldn't have done much more than that, given that the world decided to approach the problem this way. What I want to get at is we could approach the problem differently. Okay, so this is a picture. You may have seen a picture like this. This is CO2 in the atmosphere. It's measured from Mauna Loa, top of a mountain in Hawaii. And the black line going up is the CO2 on average, and the red line are the variations you get seasonal because of deciduous forests in the northern hemisphere. The green line here is when the negotiations began. So I want you to look at the before and after, and then tell me if you think the negotiations have been successful. Now, we don't have the counterfactual of what would have happened without them. I mean, maybe emissions would have gone, concentrations would have gone up even more, but actually, I think it's fair to say the full effect of 25 years of unprecedented negotiation is basically very close to zero. It's so close that I couldn't detect anything. And yet, we claim success. So Paris, this is the lead team, and I think this team did do a brilliant job. I mean, you have to congratulate. You get the entire world to agree on something. You probably can tell from my accent. I'm coming from a very disturbed land these days, and the idea that people could agree on something is itself astonishing. But really, let's not be bewitched by this, because this is not a great agreement. Okay? It's not. I'm not putting it down. I'm not saying we shouldn't do it. We should do it. We should make the most of it, of course. But we need to do much better than that. This is an analysis produced by the UN Framework Convention on their own secretariat. So these are the insiders. This is as close as you get to the insiders of this whole game. And this is their analysis of all these voluntary contributions called INDCs. So this is part of the jargon. It's almost like learning a foreign language when you work in this field. You have to learn all these acronyms, which I'm terrible at this, as I am with language. INDCs, okay, means intended. You see sovereignty immediately creeps into the first word. Intended, nationally determined. So you decide contributions. Even that word, contributions, is stepping back from a word they used to use called commitments. So there's been this complete retreat and this salute to sovereignty, basically, is what you're seeing here. Okay, but if what the Framework Convention Secretariat has calculated is, if countries did what they pledged they would do, what would happen? Well, basically what they're saying is, historically you have that straight line on the left, the solid arrow, and then you're going to get, as a projection that's going to continue into the future, that's the dashed arrow. And then, because of the INDCs, we think there's a good chance we're going to drop that just a little bit. That's the pink arrow. Okay? And that's assuming that countries will fulfill those obligations. And I'm going to tell you in a minute that I'm skeptical about that. But the most important thing to take from this is, until the year 2030, the projections by the Secretariat are that global emissions will keep rising. It is impossible for the world to meet its declared goal of stabilizing the climate at something like a 2-degree centigrade increase in mean global temperature over the pre-industrial level. It's impossible to do that with this trajectory. Full stop. Remember I told you, basic emissions have to go down to zero. That's their analysis of what this great achievement in Paris, just so you understand. This is another picture. What they're showing here is what you would need to do if you wanted to meet that goal of staying within 2 degrees C. So the black line on the left, that's actual emissions. The orange line, more or less, the band is more or less representing these INDCs, these pledges. And the blue is what you have to do if you're going to actually meet the goal. Not the probability 100%. I mean, if you take the turquoise one on the right, that probability of meeting the goal is less than 50% with that trajectory. Less than 50%. And you'll notice what happens. The Paris takes us up like this, and then all of a sudden, in 2030, boom, the world goes like this. So what happens in 2030? I call that a miracle. And I'm not going to bank the future of the planet on a miracle. Okay? This is our job to try to address this problem. Now, going to what we can do in the science, Astrid and I have done an experiment on Paris. And because one thing that was novel about Paris is that countries are going to make these pledges for what they're going to do, and they're going to be, there's going to be this, we're going to look at each other's pledges, and we can make a comment if we think that countries are pledging enough, maybe they should do more. And we're going to follow and see what countries actually do, and if they don't do what they said they're going to do, then we could grumble, we could say something, and maybe give them some shame, or maybe give them some encouragement. And the question is whether that process will make any difference. They went this route without any evidence that it would work. That's the thing that I find annoying. You're betting the future of the entire planet, okay, I'm putting it kind of dramatically, on this. This is the best you can do. Now, given sovereignty, given the approach they're taking, maybe it is. Anyway, Astrid and I can go to the laboratory, we can ask whether this kind of arrangement changes behavior. And what we've done is we have an experiment in which a group of players are playing, they're contributing poker chips. So we like the gambling metaphor, but not always with cards. Poker chips. And they're going to choose a group goal. They're facing a problem that actually looks, we don't mention the words climate change, but the problem is similar to climate change in the way it's constructed. They're going to make a proposal for the group as a whole should do. That's the goal, like a 2-degree goal. And then they're going to make individual pledges of how they're going to contribute towards the group goal. And then finally, they're going to make actual contributions. And all of this is going to be embedded in a system that allows for pledge and review. They'll look over each other's shoulder, naming and shaming, that kind of thing. The first treatment on the left here, no review, is the old system. There is no review. And then you're going to have a review that's placed at the very beginning of this process, and then the midpoint, and then later on. And what you actually find there, if you look at the red band, the proposals for the group go up, the pledges also go up, and the contributions, they look like they go up a tiny bit. What's actually happening is that the review process causes proposals to go up, like in Paris, we went to keep temperature well below 2 degrees C, which is basically no one believes that's possible. So, to agree something that people don't even think is possible, makes people feel good, I guess. Then they make the pledges. The pledges don't add up to, there's no way you can, if you fulfill those pledges, there's no way you can meet the proposal we just chose. And then finally, actual contributions come in a lot below the pledges. There is an effect in terms of what countries say they will do, which is what we heard in Paris. In our experiment, anyway, we'll see what's going to happen in the real world. This is an experiment, right? We don't know yet. But what this work is suggesting is that we should not count on Paris succeeding. I don't think we should count on countries fulfilling their pledges. Now, a lot of other things are going to change, prices, and all sorts of things are going to change in the whole global system, having nothing to do with climate policy. So it's hard to know exactly, but the case seems pretty strong that it's not going to be very effective. But there have been successes. You can come here just completely to be depressed, right? I said how to, not just not how not to save the world. There have been successes, so then the question is, why? This man, good-looking man, should be very famous, I think. His name is Ali Mau. And he is the last man on the planet Earth to have endemic smallpox. And he became infected with smallpox in the autumn of 1977. And once it was discovered, he tried to hide, but once it was discovered that he was infected, the authorities, taking Hobbes's advice, vaccinated people who had come in contact with him that they knew about, and then people who had come in contact with the people who had come in contact with him, and so on and so forth in these kind of concentric circles. And because they did that, they were able to get rid of this virus everywhere on the planet, except in a few laboratories. Okay? And today, at least as far as we know, smallpox only exists in 2 laboratories. I think this is probably the greatest achievement of cooperation in human history. Because of this, millions of people, their lives have been saved, and the vaccine that we used to protect against smallpox was a dangerous vaccine. It was expensive, but also killed 1 out of 1 million people. You couldn't use it very safely with people who had immunity disorders and so on. So the world is much, much, much better off for this. Now, why did this succeed? Michael pointed to this in his remarks earlier. Well, normally what a country will want to do is it will want to have a public health policy. You know the problems in this country about the MMR vaccine. You really get a feeling there for how the state is trying to get people to get vaccinated for the benefit of everyone. But if you don't see the disease around, as an individual, you think, why should I bother? Because maybe there is a risk, and I don't like shots anyway. So you pull back a little bit, and that's what allows the disease to persist. So this payoff in the blue shows you what a country gets when it just adopts its normal public health policies. The pink one, which is lower, requires much stronger action, which is to get rid of the disease entirely just within the country. And what you see here is the payoff to getting rid of it everywhere within the country is not strong enough, so countries won't do it all around. But if you get over here, every other country does it, then the payoff jumps. And the reason the payoff jumps is that's the point at which you've eradicated the disease, so now it's gone everywhere. And because it's gone, you no longer need to vaccinate for it. So people are not dying from it anymore, and you don't have to vaccinate. So you're saving money, you're saving all the pain and anguish and incidental deaths associated with that. So that's this huge benefit. And the thing to notice about this is because the curves cross, the incentives change. So that if you believe everyone else will not play their part, you're not going to play your part, and you'll be over here. But if you have confidence that the other countries will act, then you will absolutely act. And this is why not only we succeeded with smallpox, but the current effort to eradicate polio has been right on the verge of success since the year 2008. I'm not kidding you. I can tell you a lot about the polio effort. It has a lot of problems, but those problems are largely technical problems. They're not incentive problems. So here's a great achievement, and the reason it worked is that the incentives here are very different than for climate change. Now, this raises the question, how much time do I have left? I have this terrible tendency to go on. 15 minutes, right? Now, you might look at this description I gave of climate change, the card game, and so on, and say, well, you know, is that really the problem we face? Because the scientists are telling us that all these catastrophic things might happen or will happen. And so I want to raise the question here about whether that game is right. Maybe we got the game wrong. Isn't climate change dangerous? This is a picture I got from a movie called The Day After Tomorrow, which I personally did not watch. Because, you know, Hollywood wants catastrophic climate change to be, you know, it has to happen Tuesday afternoon between 4 and 5 o'clock. And every night it has to be this cataclysmic thing that's biblical. And I think it may not work out quite like that. But there are tipping elements. So the concern about climate change is not just an increased temperature and things will get a little bit worse. It's also that there are systems that we rely on that are very vulnerable to changes in the temperature. So if you had stable systems, the temperature increase may not be that big of a deal. But if you have systems that are potentially unstable, they have a tipping point, and temperature gets too high, the system may collapse. Collapse, by the way, may not happen Tuesday between 4 and 5. You know, it may take, in some cases, it could take centuries. In some cases, it could be very quick. Depends on the system you're talking about. But you know, some of the things that people have been focusing on would be collapse of the Western Antarctic ice sheet, for example, which would increase sea level by several meters, or melting of ice on Greenland, changes in the monsoon, all sorts of things like that. So these are in many ways the consequences of climate change that should really take our attention. Now, if you have this, then you could have a picture like this. This is not the prison dilemma I showed you before. Remember, those two curves were parallel and they never crossed. But now you have the curves crossed and they start to look a little bit like smallpox. So what's happening here is, with smallpox, the world's cooperating so that we can get rid of something and avoid something that was already bad for us. Now, think about climate, because of climate catastrophe, the world's going to cooperate to avoid something that would have happened if we didn't cooperate. So it's kind of a similar situation, and you might think it would work. The difficulty is, yes, if you knew that there was going to be catastrophic climate change, you knew it for sure. And you knew the tipping point, where it was. So you knew what the entire world had to do collectively, Then you have a meeting of the entire world, and you agree we should meet this goal. Everyone's going to say, yes, of course, our survival is at stake. Now we're going to allocate the responsibility for fulfilling this goal. There'll be some kind of complaints. I don't think very much. I think they will agree. And then countries will just go off and do it because everyone knows everyone has a strong interest in doing it. I'm very confident this arrangement will work. However, the problem with climate change is that all those fears I've described are correct. That's how we understand the science of climate change. And yet, the threshold is uncertain. And that is part of the science too. And uncertainty about the threshold makes things very, very difficult. So what theory can suggest, this is the kind of work that Michael and I do. This is theory. So we scribble a lot of pieces of paper, these elegant models. We think they're elegant, you probably think they're weird, but we think they're elegant. We're mesmerized by them. And what the theory suggests, very simple, by the way, it's amazing how something so important could be written down and be so simple, I think. Uncertainty about the impact, so what happens if the West Antarctica sheet collapses? The consequences going to be huge for us or not so great? Can we adapt? All those kinds of questions. The expected value, what you think is going to happen, matters, but the uncertainty around it doesn't matter at all. That's what the theory predicts. It doesn't matter at all. Whereas, where the threshold is that would trigger this catastrophe, that matters. That's crucial. If the threshold is certain, we'll get our act together, we'll avoid a catastrophe. We'll do it. You know, think about how the world organized to fight World War II. That's where the whole idea of the United Nations came from. That was a successful effort. So the world can cooperate if the imperative is overwhelming. But with what the model, what the theory predicts with threshold uncertainty is that you're back to the prisoner's dilemma game. So if you have certainty, you have a coordination game, which is like the smallpox example, which we did well, right? So that's a good thing for us. In a way, catastrophe is good for us because it'll get us to take things seriously. Mother Nature is doing the enforcing. That's the cool thing about that. But if you have threshold uncertainty, the theory prediction of the prisoner's dilemma, and then we're in a situation where we want to do even more than before because now we're worried about these tipping elements, and yet we're unable to do it. We can't change our behavior. So we feel even worse. And Astrid and I did an experiment. And what you have, we did an experiment with groups of 10, and there were 10 groups playing each what's called a treatment. So here you have certainty about everything. Here you have uncertainty about the impact, which I told you shouldn't matter according to the theory. Here you have uncertainty about the threshold, which I told you was crucial. And here you have uncertainty about the impact and the threshold. Now what you see is because these colors are the same and these colors are the same, that the uncertainty about the impact really doesn't matter. The experiment shows that. The theory is that. That's pretty cool. Okay? So we don't have to worry about that. However, the theory predicts that uncertainty about the threshold should be crucial, and it is. Because here you have certainty about the threshold, and in 18 out of 20 cases, catastrophe was avoided. And here you had uncertainty and catastrophe was not avoided. In fact, the probability of catastrophe is 100% in almost every case. Now you might wonder what's going on with these two cases up here in red. This is where the experiments get to be quite fun. It turned out that, remember you had groups of 10, it turned out that in each one of those groups you had one person. I know you're thinking, God, there's only one person. There's one, there wasn't always one person. In 18 of the other groups, everyone did the right thing. I mean, that's pretty cool, okay, I think. But you had one person, and that one person said he or she was going to contribute a lot, and they contributed nothing. And I can guarantee you that those people would have felt bad about it afterwards because they lost out. Of course, their peers lost out too, but they lost out. I make a bet they would sort themselves out pretty quickly. What I'm trying to get you to see is that 2 people have 200 misbehaved. And in my experience with human beings, that's a pretty good ratio. So this idea of facing a catastrophe, if the threshold is certain, is very powerful for changing how people behave. Very powerful. Okay? But unfortunately, the science of this problem means the thresholds are uncertain, and we're in that red territory. So with that prisoner's dilemma game, don't take it literally, but as a description of the problem we face, I think it comes pretty close to the characterization. Now, eradication the problem was intrinsically a coordination game. It wasn't as if countries had to decide it was. Nature told us it was. You had to get rid of the disease in every single country in order to eradicate it globally. It had to be done that way. The threshold was certain, by the way. You had to have 0 cases. Now, the question is, once you've understood that comparison, can we make, Mother Nature is in a sense not cooperating with us, that's where the uncertainty is coming from. Can we make our own coordination game? So this is the idea of strategy, which is how I think we need to think about this problem. Now, I'm going to explain the strategy. I want you to know, before I show it to you, that I'm not proposing this. Okay, so when you see it, this man is crazy. I'm not proposing this, but this is an intellectual exercise. We're at the university here, and this is for getting us to think. Okay, so here's the proposal. I don't know if you know the movie, Dr. Strangelove. The movie, which I won't make any comments about contemporary politics. But anyway, this is the idea that it belongs to Herman Kahn and Thomas Schelling, who I mentioned before, is also involved in this movie, believe it or not. The guy is to use strategy to make the world safer with nuclear weapons. This is the thought experiment for climate change. What my proposal is, it's built on this idea of mutually assured destruction, is we're going to connect all the nuclear warheads in the world to a computer that's taking readings from Mauna Loa. I showed you Mauna Loa before. The readings today are over 400 parts per million. So let's give us enough time to sort ourselves out. And let's say we want to cap it at 500, okay? So it'll give us a little time for it. And we're going to program the computers. So when Mauna Loa, the computer's there, read CO2 in the atmosphere at 500 parts per million, all of the nuclear warheads will be detonated. And none of this can be changed. Once it's programmed, it can never be changed. Now, if that were the case, my question to you is, do you think we would then reorganize the global economic system, the energy system, to avoid catastrophe? I've asked this question to other groups, and people are sometimes very skeptical. I'm pretty confident we'd do it. I mean, I'd say at least 198 out of 200 would be the ratio. I think we'd do it. I'm pretty confident we'd do it. And the reason is we know the threshold is 500, it's certain, and it is truly catastrophic. So we would get back together. But of course, I'm not proposing this, and nor it turns out that Herman Kahn never proposed that, even though he's sometimes attributed, the proposal is sometimes attributed to him. But it does raise our imaginations to ask the question, is there an acceptable strategy that we could adopt that would have an effect to change our behavior? Because we're changing, not ourselves, we're changing the game, and by doing so, we change how we want to behave. So here's another problem, another beautiful problem. I should mention, by the way, I'm thanking people today. One person I've learned a lot from is someone named D.A. Henderson, who led the smallpox eradication effort, who died a few months ago. He gave me an incredible amount of his time so that I could understand how that whole process worked. And on the ozone there, I not only speak with my peers in the academic world, but also practitioners, and Richard Benedict, who was the chief U.S. negotiator. I spent a lot of time with him to try to understand how the reality of all this works. This is the latest picture of the ozone layer. It was taken on October 9th. And you can see the hole over Antarctica. It is getting smaller now. It is getting smaller. And it will go back to where it was before we throw the CO2 in the atmosphere. This will be one of the greatest achievements in human cooperation. We can do it, but then you have to ask, why are we able to do it? Well, in the case of CFCs, now this took some investigation. Okay, the first paper that Michael mentioned didn't quite get there, and I knew it didn't quite get there. This is one reason I have this obsession. I keep working on these problems. He keeps working on these problems. It took me a while to figure this out, but what's really going on here is you're negotiating an agreement about changing industry, changing innovation, but doing it against the backdrop of globalization. And globalization, in a way, makes everything difficult because industries can move to other places and so on. So in a way, it makes things more difficult, but actually, for the same reason, it gives you leverage. And that's what happened in the Montreal Protocol. And this is why this treaty is so ingenious. So what this treaty could have done is it could have done like the climate treaties and just told every country, you know, you really should cut back, and you should do this voluntarily. But what it did instead was to say, you need to cut back on your consumption of CFCs. That's like cutting back on consumption of fossil fuels, so similar to Paris that way. Cut back on your production of CFCs. Now, no one is negotiating a reduction in oil production. Well, OPEC, of course, tries to do that all the time, but we're not negotiating around that. So that's already a difference. And then finally, the agreement imposes a ban on trade in the CFCs between the countries that are in and the countries that are out. And that ban completely changes the incentives. And instead of getting what would have been the first dilemma with those two curves going up in parallel, which is the problem that we're not good at addressing, instead you got the curves to cross. So again, this was a deliberate move, a strategic move by an unusual set of brilliant negotiators. So the reason this works is that if few other countries are in the agreement, you really don't want to come in because not only is it the usual free riding problem, but now you can't trade with those countries in the CFCs, which is going to hurt you even more. But if you go to the other end here, where everyone else is in, if you're not in, you get to free ride, as before, but now you also can't trade with the rest of the world. And if the loss in the gains of trade are big enough, those payoffs are going to cross, and now you're going to have a tipping point in a social system, not a geophysical system, a social system. And if you can assure everyone that enough players will get rid of the CFCs, they all want to get rid of the CFCs. And in fact, a former student of mine, Ulrich Wagner, who's this brilliant piece of work, empirical work, showing empirically that this is exactly what happened with the Montreal Protocol. Now, getting back to climate, it turns out that we have one really good climate treaty, and it's not any of the ones I mentioned before. It's the Montreal Protocol, which was never intended to address climate change. But it turns out that the CFCs and related chemicals that deplete the ozone layer also are greenhouse gases. So if you have an agreement that is successful in getting rid of them, even without caring about climate change, just because you do care about ozone protection, then you've achieved a lot. And this paper, which came out in the PNAS in around 2008 or so, I forget the exact year, 2007, 2008, by some Dutch researchers, they actually showed that the Montreal Protocol achieved 5 times as much as the Kyoto Protocol aimed to achieve, but never did. 5 times as much, and you don't even talk about this. No one's even aware, very few people are even aware of this. So think about it. When we try to address climate change, we fail. And when we weren't trying, we succeeded. And I'm interested in this. Well, why is that? Well, the reason is the Montreal Protocol is a coordination agreement. And that's what the world is good at. So, you won't be surprised that my conclusion from all of this is to address climate change, we need to do what the world is good at doing. Ask countries to do what they are good at doing, which is coordination. Don't ask them to do what they're bad at doing, which is volunteering to hand in the red cards when national self-interest is always pulling in the other direction. You know, we can wring our hands and say, you know, that's terrible that you feel that way, because you really should just do the right thing. We can do that. We've been doing it for 25 years. But I think it would be a better arrangement just to create the incentives, like we did with Montreal, like we did with Smallpox, what nature did it for us with Smallpox. And those are issues you don't even hear much people discussing because they work. We tend to ignore everything that works and we focus on the things that don't work. But the way to learn about the world is to look at situations where things work and where things don't work. Now, the world is doing something really good right now, which is to negotiate an amendment to the Montreal Protocol to phase out another chemical called HFCs, hydrofluorocarbons, which were actually developed as a substitute for the nasty CFCs that deplete the ozone layer. So the HFCs don't deplete the ozone layer. So that makes them very good. But they are incredibly powerful greenhouse gases. And we included them under the Kyoto Protocol and achieved virtually nothing. But now there's a move to negotiate an amendment to the Montreal Protocol that will limit HFCs under that agreement, which, as I explained, is a good agreement because it's a coordination agreement. And I'm sure that will be successful. Now, that will not solve the problem of climate change, but it does get at one of the critical gases. Remember a list? Took that one off the list. That's pretty cool. That, I think, is the best news I've heard on climate change in 25 years. And you probably haven't even heard about it, because no one talks about it. but I think this is the best thing that's been done so far. Will be done. I'm very confident this will work. Now, what else do you do? This is a very provocative idea. I'm almost done. I'm going to talk about tomorrow to a group that Smallpox, Michael's working on. And William Nordhaus at Yale University has come up with this idea of a climate club. There's a lot of talk about clubs today, because clubs are just, everyone kind of likes clubs. I know, we don't like them too, because particularly if we're excluded from them. But something club is kind of very appealing. People kind of like the name, so it's very fashionable right now. Anyway, what he argues is that you could get a group of countries, like-minded countries, that want to act on climate change, and they will not only act on their own, as in Paris, but they will actually impose tariffs against countries that don't act with it. That's the stick. Thomas Hobbes is coming back. Okay, that's the stick. Now, one thing I want to tell you about his work is that it only works in his model for a carbon tax up to around $50 per ton CO2. I don't have time to explain exactly what this means, but in terms of the problem of climate change, that's actually not a very high number. So this is not going to save the day. Another thing about this is I would be a little worried. I think it's an open question if this is a good idea, so it's provocative and exciting. But what he's basically saying is those trade rules you've been negotiating for the last several decades, which I know it's fashionable to not like them, but actually they've delivered a lot of benefits to the world. But he's saying those trade rules, throw them out. Because now all the successes on trade are conditional on you doing what we in the club, self-appointed guardians of the planet, we think you should be doing. And I think that that's a very provocative move and could bring about retaliation. And in his model, he assumes there is no retaliation. Well, models can be very careful because an assumption like that could turn out to be very important. But I do think that even leaving that provocative idea aside, there are other things we can do that are much more straightforward and less risky in a sense. And what we basically need are a lot of agreements. So we'll get this new one on Montreal Protocol. We need agreements on things like international aviation, international shipping, the way we manufacture aluminum, steel, and cement, on electric cars, on having more of a global grid for electricity distribution. All of these things would help or exploit this possibility for coordination. Maybe the questions I could explain a little bit more what I mean by that. But that's a very different approach that we've taken so far. The nice thing about Paris is we can continue with Paris. Paris will have its followers, but you can do other things on the side, just like we're doing the Montreal Protocol Amendment right now. We do all these other agreements, and we should be pursuing them right now. I think it's a priority. And finally, going back to the seriousness of this problem, if you really believe that global mean temperature change should be limited to something like 2 degrees, or even 3 degrees, or the way we're going, even 4 degrees, then I think we need to think about different technologies. And it's not that the solutions are to be found in technologies, it's that certain we will behave differently as a group. That game we played will change as the technologies have different properties. So it's not only nature, but it's also the technologies themselves. Now, one idea that I think deserves more attention than it's been getting up to now is something called carbon geoengineering, which is not the scary geoengineering they heard about. I'm going to do that in a second. But this is about you build machines to take CO2 out of the air and then store the CO2 safely someplace like in rocks. So I have colleagues that do this. They take it out of the air, they can do that, and they can store it in places. They fix it in things like rocks, so it'll never come out again. Nature, by the way, does that. If you wait thousands of years, that CO2 in the atmosphere will eventually be taken out of the rock. Okay? It just takes a long time. In a sense, that's the problem. There's virtually no research being done on this today. And I think that's outrageous, because this is the only backstop technology we have for dealing with climate change. There should be a program for research. And in particular, I believe that if this technology has certain properties, it's possible that this could be a coordination problem. And we'll solve the problem not by changing behavior worldwide, but by building a project, a public project that's big enough that can remove the CO2 from the atmosphere. We don't have to worry so much about behavior. I just think, I'm not an advocate for this, I just think it's outrageous that there's not a serious study being done on this now, and it deserves a lot more attention. And the last one I want to mention is the scary form of geoengineering. You've probably heard of this idea of geoengineering, which is they would do something like throw particles into the atmosphere, stratosphere, to reflect light away from the Earth, and so to cool the Earth, to offset the effect of greenhouse gas concentrations. Now, you could do this in modified temperature, and we know that's true because Mother Nature does it through volcanic eruptions. So we know that's true. It's not a substitute for the greenhouse gases in the atmosphere because they have different effects on radiative forces. So it's not as if the global climate would be the same when you do geoengineering as when you deal with the problem properly, right? The carbon geoengineering is similar because you're taking CO2 out of the atmosphere. On the other hand, I think people should be open to the idea, if you really think catastrophic climate change exists, and you really think we can't go beyond 2 degrees C, and you know that this can be done, and you know it would work, I would like to answer the question as to why we're not looking into this more carefully, because if the day comes when we think something needs to be done, wouldn't it be useful to know whether this would work, what its risks are, and so on? Again, there's kind of a silence around this. I'm not an advocate for this. I don't get out of bed saying, I wish we could do this. I wish we could do things properly, but there are reasons why we're not doing it properly, and I think we have to be open to these other suggestions. This one, as I thought about it more and more, this is almost like science fiction. This is not, straight science, because you're talking about a future world, future people, future governance arrangements, future technology. It's a different kind of thing, and I'm not even sure I'm equipped to think about it very carefully. But I'm guessing that what will happen is instead of there being one global solidarity about flicking a switch, throw particles in the atmosphere, probably what you'll have is many different countries doing many different things. And all of that adding up to deliberate interference, which is on top of our inadvertent interference. People seem to care if it's deliberate or not, but any interference is an interference. And then there will be a need to coordinate around that. And I think if we blind ourselves to this future, we may end up finding ourselves going down a route that we're completely unprepared for. So I'm not suggesting this is any kind of good thing. I'm also not trying to scare you about it. I think there's a lot we don't know. But I think if we don't consider these options, we're also doing the future a disservice. Remember, this problem is going to be with us for millennia. Thank you very much.
Thank you very much, Scott. My name is Michael Fines. I'm the head of the department in economics. I wonder why I'm here. It's because there's not only coordination in this university, there's also cooperation across faculties and disciplines, and that's a joint event, IPR and economics. So we have a little bit of time to take some questions. Who would like to? Yes.
You mentioned uncertainty about the threshold of catastrophe being a problem. I wondered whether it's an even more difficult problem than you implied, because the threshold of catastrophe is different for different regions. So there's not even going to be agreement about what that threshold looks like.
Yeah, I think you're right. I think that if you try to say, I think the more you look at this, it's very difficult. You've got, first of all, you've got these different systems, and they have different points. The uncertainty around it is really quite huge. There's another very interesting paper where scientists who work in the area, who are experts in this, were asked to give their subjective views based on what they know about what tipping points were for particular systems. And there was a lot of us, not about everyone, some like the Greenland, melting-wise, people have a lot more confidence around that, but some of the other ones are really quite uncertain. You raised another issue, very, very important, which is in these games I showed you on the board, everyone's symmetric, we're all the same. Of course, we're not all. Now, one of the problems with climate change is that it will affect different countries differently. And right now, it's probably fair to say that the countries that are the most vulnerable to climate change are the poorest countries that lack the wherewithal not only to develop, but to adapt. The two are almost synonymous. And yet they, because they haven't developed, play virtually no role in the problem. So I think there's a very serious issue here of fairness, obviously, but also widening existing inequalities and the pressures and strains that will create. So I think that's a very good point. There's unfortunately, maybe a crass way of putting it, but Mother Nature isn't cooperating with us by allowing that to be an easy vehicle for us to organize ourselves. We're going to have to find another vehicle to do that.
First, thank you very much for that. Fantastic. But looking through your suggestions, you don't seem to touch upon the agriculture industry at all throughout it. And I wonder what your stance was on the agriculture industry.
Oh gosh. I don't know a lot. I really won't say very much. I don't know a lot about it. Obviously, quite a lot of emissions come through agriculture. There may be things we can do on coordination. I haven't given that much thought. I have a colleague who has been thinking about that recently. I'm a little wary of areas where measurement and so on starts to get really problematic. I'm looking for as much simplicity as possible. So I recognize it's a problem. I leave that to you and the other experts, and my apologies for not giving you a better answer.
What question?
Or unless you meant agriculture being damaged by climate change.
No, the agriculture industry is like the food, sort of the food sector and the agriculture market.
Yeah, I mean, last thing, I do want to say one thing about this that is important, and that is that one of the areas that we're most worried about is actually not necessarily sea level rise, not only sea level rise, but also the global food system, and whether there could be a big effect. There's some very interesting research, including by a colleague of mine, Wolf Schlenker, showing that you not only have these nonlinearities in the geophysical systems, but also with crops. And you particularly get a sensitivity, it varies a little bit with the crop, but you get a very deep sensitivity in the neighborhood of around 30 degrees centigrade. Now, we don't know the potential for advancement in science to engineer varieties that can perform better under these changing conditions. But there is a risk that the catastrophe that we're thinking of won't actually come from these geophysical systems. It may come from our own agricultural systems. It may also come from just our social interactions, work linking climate change to violence, for example. So I think these are really early days. We're moving into these uncharted waters, and but there is some interesting recent empirical work showing that these risks should be a great concern to us.
What question?
Yeah, it's weird. One of the next problems, which I foresee is on a global scale, is that of ocean plastics, where we've got 8 million tons of plastic being added to the ocean every year, and it's just going into international waters, and no one's kind of taking ownership of that. I don't know if you've looked into this, or any of these models that you've looked at today could be applied to that. Yeah, it's just.
Yeah, it's a great question. I thought about it a little bit. I have a house in Cape Cod. I walk the beach a lot, and even nice people on the boats, they can't control their plastics. You get all sorts of things that wash up on the shore, and of course, as you know, that there are these certain parts of the ocean where you get these incredible aggregations of these plastics, and there's a lot of research showing the damage they cause to the aquatic life. I have not looked into this, but I think. Modifying behavior would be different. Modifying the technology is a different matter. I would probably be inclined, I haven't done work, I would worry more about modifying the technology, meaning the degree to which the materials can degrade. And maybe there's an effort that can be taken for cleaning up certain areas as an aggregate effort. That's great. I like that thinking too, that you can take these ideas and apply it to it. I haven't personally worked on it. I am working on the oceans right now, but mainly in terms of fisheries, not
that Hi. What was it about the Montreal Protocol that successful? Like, why was it a fluke that it was just so good? Because if they did it in Montreal, why couldn't they do it again in Paris? Was it a particularly good, like a set of negotiators, or did they not realize that it was going to be so good at the time, so more people agreed for it?
Yeah, that's a great question. Now, one thing I'll say is that people have strong views about Montreal. They think it was really easy. And there's this expression, you know, that revolutions, after they occur, look to us as being inevitable, but before they occur, they appear impossible. And I think there's some of that going on, and how people have interpreted Montreal. The circumstances were a little easier than climate change. Okay, maybe a lot easier in many respects. But there was a lot of scientific uncertainty in 1987. There was a lot of opposition by industry. In those ways, similar to climate change, of course, there's a narrower problem. Our whole economic systems are not built on fluorocarbons, so a narrower problem. But I think the genius of Montreal was that it focused on creating these incentives. Basically got everyone to believe that this world we had become accustomed to, in which countries were using CFCs, was not going to exist in a few years. And the future world was going to pay off for the players that developed the substitutes for the CFCs. And once everyone believed that the firms all turned their interest towards the substitutes, not try to make money off of the original CFCs. We've not had that same transformation in our energy systems. And when the system works well, you'll see that kind of transformation. But it wasn't the people. I mentioned Richard Benedict, who was one of the chief negotiators on Montreal. Richard actually advocated for a system very similar to what we have on climate change now in the late 1980s, right after Montreal. And he admitted to me later, and one of the things I really like about people like that is that you're in a position of having to make decisions. How many of those people ever admit they made a mistake? He admitted to me that was a mistake. He got the strategy wrong. I think the reason they've avoided the same system is partly you really would have to ask fossil fuel producers to stop producing. I mean, tell the Australians stop producing coal. It's at that kind of level. And also, everyone's avoided. And also, I think there's a greater worry about the trade side, because instead of restricting trade on CFCs, which is a pretty small part of the economy, every single thing we do, including my lecture, contributes to CO2, and everything's affected by the climate. And if you apply trade measures, I think there is a risk. It's not. I'm not convinced yet that it's any kind of easy solution.
Okay, I'm sorry I have to be aware of the time. So I would like to thank Scott very much for his talk. I think it was very inspiring. I think people will continue to discuss. I think it was a fantastic talk, and I could learn a lot. The first one, he was talking a lot about tipping points, and you may recall, he says, there can be a catastrophic event, and it's important to make a difference if you know for certainty there's this tipping point. And he proved the theory right, because obviously he was uncertain about the exact time he could talk. I went over that. So what I take away from that next time the tipping point must be that his micro is switched off. The other thing, and the Vice Chancellor confirmed me that, what I said before in my rotation, was, you may recall, that what I think is very special about Scott, that he can reach out not only to economists, but also to non-economists. And obviously you reached out to the Vice Chancellor, because when you talked about this card game, she was not so much interested in the card game, but she's a true academic, and she immediately spotted that you made not very clear your assumption, because she said you have to say that there are more than 5 players, otherwise your example doesn't work. So I think this is remarkable, and she spotted that immediately, so that I think proves it, that with her background in psychology, that it was easy to follow your lecture. So let me finish this public lecture and this honorary degree ceremony by thanking Scott for coming here. I'd like to thank the Vice Chancellor to make herself available to that, to Nick, the Director of IPR, and in particular I'd like to thank you for coming here and participating in the debate. Thank you very much.